VLSos here. This is a video lesson on a power property, negative exponents. What kind of power would use this property? Let's give an example. 3 to the negative 2. It's a power, its base is 3, but its exponent is negative 2. How do we think of that? 3 times itself, negative 2 times? I'm not sure I know how to think of what it means to multiply something by itself a negative amount of times. Well, we have a property to deal with negative exponents. That's what we have here, an exponent that's a negative 2. And the property looks like this. Any power with any base raised to a negative exponent, in this case negative n, can be changed into 1 over that same base to a positive n. It works that way. We could use product and quotient power properties to investigate why this works. But in this case, if we use the property 3 to the negative 2, we can convert this by showing as 1 over that same base 3 and then change the sign of the exponent. It was negative, make it positive. 3 squared is something that I'm familiar with thinking about. 3 times itself. 3 squared is 9, so we could simplify this further as just 1/9. And we're finished. Let's give another example. 1 divided by the power x to the negative 4th. Again, we have a power with a negative exponent. The base is x, the exponent is a negative 4, but this power is also in the denominator of a fraction. We have another form of the same property. When we have 1 divided by a power b to the negative n, then we can convert that into a power with the same base and change the exponent from negative to positive. This property looks a little bit different. These two properties are essentially the same. They're both how to deal with the negative exponent. But it can be helpful to see what happens when that negative exponent is in the denominator of a fraction. Now there's a way to think about these two properties, which we'll write here. You can always make these changes to a power. If done at the same time. And what you do, what these two properties are essentially doing, can be thought of this way, doing these two things. Take the reciprocal of the base, and that is, the reciprocal is simply just switching numerator and denominator in a fraction. So if you take the reciprocal of the base, then the second thing that you do is change the sign. Sign is in positive or negative. Change the sign of the exponent. That's what these two properties are doing, and that's what we've done when we use them. Take a look. In this case, if we have b to the negative n, then we can take the reciprocal of that base b, which is 1 over b, and change the sign of the exponent from negative to positive. In this case, the reciprocal of the base we think of as 1 over b. So the reciprocal of 1 over b is just b. We are ignoring the b over 1 and change the sign from negative to positive. Let's give another example. 8 times 2 to the negative 3. I have a number times a power, and the power's base is 2, and the power's exponent is negative 3. I'm going to deal with this negative exponent by taking the reciprocal of the base. The base is 2, so the reciprocal of 2 is 1 over 2, and changing the sign of the exponent. It was negative 3, I'm going to show it as positive 3. I've done those two things at the same time. I've used this power property, and I'm still multiplying by 8. Simplifying further, I still have this 8 times. Now 1 divided by 2 to the third. 2 to the third is 2 times 2 times 2, which is 8. So 1 over 2 to the third is 1 over 8. And 8 times 1 over 8 is 1. So what I started with simplified quite nicely.